All right, let's get right into it. Today, we're talking about the architecture that is, and this is not an exaggeration, running almost every single modern AI you use. We're talking ChatGPT, your coding assistants, all of it. We're talking about the transformer. And we're going to answer the big question, how on earth did AI get so good at understanding what we're saying? So let's pull back the curtain.
You've been there, right? You're deep into a conversation with an AI, and it pulls out a tiny detail you mentioned like 10 minutes ago. It feels kind of spooky, almost like it's reading your mind. But it's not magic. It's a really brilliant piece of engineering that solved a huge problem in how machines used to read language. You know, the entire revolution really boils down to this one single shift in perspective. We went from processing language one word at a time in a neat little single-file line to a totally new way, where all the words can look at and interact with each other at the exact same time. It's like going from a one-on-one conversation to a massive party where everyone's talking at once. And that changed absolutely everything. But to really appreciate just how big of a deal this is, we first have to understand the massive wall that AI research had slammed into. So let's take a look at the old way of doing things, the sequential bottleneck. Before 2017, the kings of the hill were models like recurrent neural networks, or RNNs, and they worked pretty much how they sound. To understand the last word of a sentence, the model had to chug through every single word that came before it, in order. It had to carry the meaning along step by step, kind of like that game of telephone. And this one-by-one process had a fatal flaw. Well, actually, it had two. First, the context would just disappear. Imagine trying to remember the first word of a book by the time you reached the last page. That's kind of what was happening. The signal got weaker and weaker. But the real killer was the second problem. You couldn't do the work in parallel. Your super powerful computer chips were basically sitting around twiddling their thumbs, waiting for the model to process one word at a time. Trying to train on the entire internet? Yeah, right. Forget about it. And that brings us to 2017, the moment that changed everything. And it all started with a single research paper that didn't just suggest a better way, it basically announced a whole new era.
I mean, you have to love the confidence, right? They didn't call it attention is a pretty good idea. No, they called it attention is all you need. This paper just threw the old way of doing things right out the window and introduced this radical new idea called self-attention.
So what is the self-attention thing? Well, it's pretty much what it sounds like. Instead of a word only getting information from the word right before it, this mechanism gives every single word the superpower to look at and weigh its connection to every other word in the text, all at the same time. No more waiting in line. Okay, let's make this real. Take this sentence, the cat sat on the mat because it was tired. How does the AI figure out that it is the cat and not the mat? Well, in the old models, the distance between it and cat was a problem. But with attention, the word it can literally look directly back across the sentence at both cat and mat and calculate which one is more important. It learns to draw a super strong connection, a high attention score, between it and cat. The distance just doesn't matter anymore. So how's it do that? Okay, think of it like this. It's like a tiny, super fast search engine running inside the AI. For every single word, it creates what's called a query, which is basically the word asking, hey, to understand myself, what kind of info do I need? Then it looks at the keys from all the other words. The keys are like little labels that say, this is the kind of info I have. When a query finds a key that's a good match, it pulls the value, the actual substance, from that word. And this happens for every word, all at once, in a flash. And here is the real stroke of genius. This whole complicated search and retrieval process, it's not a bunch of steps. It's just one giant math problem, specifically matrix multiplication. And you know what modern GPUs are incredible at? Yep, matrix multiplication. So we can just throw the whole text at the GPU, and it processes everything in one massive parallel operation. The bottleneck wasn't just solved, it was completely obliterated.
Okay, so self-attention is the powerhouse. It's the engine. But it's part of a bigger, really elegant structure. So let's take a quick look at the full transformer architecture.
So a full transformer isn't just one attention mechanism. It has lots of them running in parallel, which is called multi-head attention. You can think of it like having a whole team of specialists reading a sentence at the same time. One expert is focused on grammar, another is tracking who's doing what to whom, and of course, since everything is happening at once, it adds a clever trick to keep track of word order. I mean, without that, the dog chase the cat would be the same as the cat chase the dog, which it's not. And this amazing, flexible toolkit lets us build two main flavors of models. On one hand, you have what are called encoder-only models, like BERT. These are phenomenal at understanding text. Think about what powers Google search or analyzes if a movie review is positive or negative. Then you have decoder-only models, like the GPT family. These are built for generating stuff, writing your emails, coming up with stories, and, of course, powering the chatbots we're all talking to. So we have this brilliant new architecture. It cracks the context problem, it smashes the speed problem. So what happens when you unleash that on the world? Well, you get an absolute explosion of scale and ability. And look, it is impossible to overstate this point. The ability to process text in parallel wasn't just a nice little speed up. It was a complete paradigm shift. For the very first time, it was actually possible to train AI models on the entire internet. We could finally let them learn from pretty much all the text humanity has ever written. And that led to, well, this. The size of the models just went vertical. We're not talking about small jumps here. We went from models with millions of parameters to billions, and now we're well into the trillions, a scale that was pure science fiction just a handful of years ago.
But here's what might be the wildest part of this whole story. The transformer isn't just for language. Not at all. It's turning out to be this kind of universal, general-purpose design for learning. They're using it in vision transformers, which see images as a sequence of little patches. They use it for audio transcription, and even in biology to predict how proteins fold. It is a single, incredibly powerful pattern for building intelligence.
And that's really the big takeaway here. When you're talking to an AI and it just gets you, it feels like magic. But it's not. It's engineering. It's the result of this one incredibly clever and efficient design pattern that lets a machine see relationships in data in a way that was never, ever possible before. Just think about that. From one single paper, one core idea in 2017, and it has completely reshaped the world of AI. And you could argue our world too. It really makes you wonder, as we keep applying this pattern to more and more problems, what's it going to build next?